So today we have a new subject. Oh, not this one. We already finished this one. Yes. 11. Okay. So I have to discuss with Dr. Muhammad to give maybe another extra subject, because like this we will finish early. Because if we will start week 11 and we are still in week 10, so we have 2 more lectures, week 12, week 13. So in week 12, we will finish all this lecture notes. Last 2 weeks. 3? No. I will try to find a new subjects for you. Don't don't do it, yeah. Give exercise, give revision, yes. It's depend on the issue like this, because me and Dr. Muhammad have to give same subjects. Okay, it's a shared course, common course. So I have to discuss with him first. If he accepts, I will give the new subjects. If he said I cannot give a new subject, then we will come and play together last 2 weeks. For example, there's some subjects that I already gave in the midterm, but not the whole lecture note. Just sub-subjects in some our subjects, not covered in the other lecture. So today we will speak about another type of a classifier, okay, which is decision tree. Actually, the classifiers that we had so far, it's all depend on statistical data. Okay, so it's considered as a statistical approach. So it's supervised or unsupervised. So far, what we get all was under statistical approach. But what if the data, it's not all related together? It's under different type of categories. So usually in a statistical approach, how we classify, by get the relation between the objects by the features, yes? And this feature, we take it as distant usually. But here we don't have relation between the features, and we cannot get distance between the features. So in this case, we can use non-statistical approach like decision tree. So we will take decision tree. Actually, decision tree also depend on data set to classify new data. So decision tree also it's supervised learning, but non-statistical supervised learning. Okay, non-statistical supervised learning. Oops. Sorry. Yes. Just a moment. Sure. Yes. Okay, sorry for that. Yeah. So, okay, this in tree, it's easy, yes. Like this, for example, like this one. Okay, age, we want to check if the person is healthy or not, age more than 40. Okay, eat fast food or not, yes, then not fat, not healthy. Sorry, yes, unfat, no, fat. Okay, so it's like this, yes, easy. No, actually, it's not that easy to get decision tree. The problem, we have questions here, yes, we have data. What's the order of this data? Maybe I can ask first if the person eat fast food, yes or not, then check the age. Okay, I will have different tree in that case. So I could have many trees for same data. Which one is the best one? This is the idea. Okay, so this just general idea. So as I said, most of the pattern recognition methods measure something that have distance features that you can calculate distance between this feature. But in some cases, we need to classify problems that have some categories, not features and distance between the features. So the normal or the regular pattern recognition here, or we name it the statistical pattern recognition approach, will be difficult to apply it here. So we will apply something that can class the categories or categorical data that it's not the statistical, so you cannot measure and this data. Yes, it's difficult to pronounce this. So for me, I see you. For me, because I have to make it to parts. But one day I will be good in Turkish, inshallah, language. One day. But when this, I don't know. Doesn't matter for me. I don't care. Just about the categories as a question. Red, orange. Okay, the size, is it big? Is it small? And so on. So we have categorized data, and we represent this categorized data, and each category could be related to another category. Okay, which category to take first in the decision tree, and which category will be down. It's make a big difference for the decision and for the process time. The issue is about the processing times that need to clarify data using this. Okay, so just some terms. Usually we name. Where is it? Okay, it's here. First node, we name it what? The root of the tree. Okay, you can imagine that the tree is upside down. On the top we have the root, and okay, so we have tree. So down what we have the roots, yes? Here the decision tree is upside down. So here in the top what we have? The root. Down we have leaves. Okay, and each one here considered as node, and between nodes we have branches or link. Okay, so this is a decision tree. So here another example for a decision tree. As you can see here, okay, we have the root as color. We have green, yellow, red. Okay, but we have other colors. No, it's depend on the data set. What we have in the data set, we have 3 different colors, for example. Okay, and about the size in the data set, okay, if sim is green and this is red, if the item is green and medium, it will be apple. Not all the items, not all the objects in the world, in our data set, we mean. Yes, we have a specific data set. This data set have watermelon, apple, grapes, grapefruit, lemon, cherry. And each one have some specification, yes, here. So, this is a tree. I need from you just to see here. We have what? Size. And here we have what? Size. So, under different branch, we could have same data again from the data set. Okay? You need to remember this because when we calculate later, I don't want from you to eliminate some categories that we still need. Some students, later we will see calculation. Imagine that if you finish from this category, you will not calculate it under another branch. But no, you will need it under another branch. Except there is one node that will not repeat it. Who will know? Who knows which node? The root. Because you will not, for example, in this tree, color, and again, you will say color. Okay, you already mentioned in this one color, because color it's belong to all the branches. So in the same branch, you will not have same category again. Size here, or shape here, size here, under shape, you can have shape here again, okay, and so on. Here you have size, you could have size again. It's in different branches. This branch, it's different than this branch, okay? Okay, so as I mentioned, it's supervised learning. So we have labeled data set. So we have categories. or classes in this data set. By the way, where is the classes? The leaves is the classes. So here it's data, category of data about the objects. Okay, and the leaves is what? The class of this object. Here we have classes as cherry, grapes, and lemon, and so on, depend on some data. So it's supervised learning, so it's a classification, but only statistical classification. So we don't have distance, doesn't matter the distance. Okay, it's simple, powerful, all this. Okay, but what's the problem with the decision tree? Okay, so let me just go for advantage, disadvantage, then I will return to that one. What advantage for decision tree? It's easy to understand it. As a human, you can read the decision tree easily. You can follow each node, each branch until it gets a category. Isn't easy to understand and interpret it. It can be used for numerical and categorical data without extensive, meaning here pre-processing. But the problem with this tree, by the way, we have many types of decision tree. We will speak about the classification issue, but also it can be used for regression. If you remember, before 2 lectures, when we give examples for regression, there was a regression decision tree. Okay. Also, it can be used for regression, but we will use it for classification in our lecture. But what's the disadvantage? We could have overfitting. Look, all the disadvantage come from the idea that you build the decision tree for a specific data set. So if you build your model, your algorithm, specific data set, so it will be working only for this type of data set. Little bit shadowing data, it's trick data. When you try to test it with different data, you will have different results. We said if you build algorithm or model for a specific data set, then the accuracy for the test data will be usually higher than, for the training data will be usually higher than the test data. Yes, this is the overfitting. There is a difference between testing and training. Training usually give you full accuracy, high accuracy, but testing will not give same level of think. This is a main disadvantage. Data. Small change in the data actually need another maybe decision tree. You need to change the tree because you will see later how to draw the tree. It's depend on some calculation in the data, and the calculation will have just the calculation make different decision tree. Okay, so it's limited to be generalized because any small change will make different decision tree. Potential of bias, it's come from the idea that you have the tree depend on just your data. So in classification, if you have missing data or outlier data, you will have problem in uh, uh, statistic data. Let's handle the mis. Actually, it's not the statistical. You don't need the data to be all. It's very far from other data, or your two of the. It's very close, same data. Two features have almost same data, so it's use similar features. This will take your model, these features, its effect become more. So it's outlier. Who's your friend here? You are signing for your friend, not for your friend. You make like this. I monitor everyone. Okay. No, just kidding. Let's see here. The most important issue, construction of decision tree. The idea before construction decision tree, we could have for same data more than one decision tree. We will take example. See, for same data, we could have more than one decision tree. Some of this decision tree will be small, some will be bigger than other decision tree. So some will be simple, some will be more complex decision tree for the same data. That's why we need to test all the attributes, all the categories, to select that one that will be best for the root. So first step, we need to select which one will be the root. For example, we have the colors, we have the size, we have the shape. Okay, which one we will take for the root? We will take the color or the size or that shape. It's depend on the data. Which one will function better? The one that will lead to the smallest decision tree. So the idea, smaller decision tree for the same data give better decision tree. Okay, so how to decide which the best decision tree? Go and draw all the decision tree for the data and select the smallest one. This is the optimal solution, but it's need a lot of processing. Yes, but the best solution here, we have some algorithms give us balance between the optimal solution and the processing time that needed. Okay, we will take one of this algorithm, inshallah, today. So first step, we need to select the best root, one of the attributes that can work as a best root. Then we will divide the training set into subsets. How many subset? Depend on the root. For example, if the root have yes and no, then how many subset we have? 2, yes and no. For example, we have root. Then if the root have categories, yes and no, then we will have 2 subset under yes, subset under no. If the root have 3 different type of categories, 3 different type of the big and medium, then we have 3 subset and so on. So we will break up the training set into subset based on the branches or the data of the root node. Then in each subset, we will test which one will be the node or the first or the second, let's say, because the root it's the first node. The second node that work best here in this place. Which node could be to have, we called it information gain, best information gain that could lead to the category in the shortest way. Okay, to get the smallest decision tree. Okay, I mentioned now information gain. So the idea here for all the subset or all the category, we have to calculate something called information gain, shortly IG, information gain. The one with the highest information gain, we will select it as a node. For the root issue, we will calculate the information gain for all the attributes. The one with the highest information gain will be the root. Then, under each branch of the root, we will calculate the information gain. The one of the subset, sub-attribute that have the highest information gain, we will take it as the node. And so on until we don't have what? Other data, other example, or other sub-category. Okay? So, if no more examples, we will mention what's the meaning of examples. Okay? In the category, we will stop. If no more attribute left, we will stop. No more attributes, means subcategories. We don't have any other subcategories. So we reach the classes. So we have to decide which class, because the classes, it's the leaf. So under the leaf, you don't have more branches. You don't have more subcategories. Okay. So in this example, we have 3 categories, A, B, C. Okay, it's just a simple example without calculation. Later, we will take example with calculation. By the way, this decision tree, it's the most subjects that have calculation and have calculations that could confuse you. So you need to focus in the calculation. Okay. But as some of other categories, it's depend or classification, it's depend in the probability also. So we will calculate probabilities, but we will use these probabilities to have data about the gain, information gain for each category. Okay, so you have to focus in the calculation. We will give this example, then we can give break before the calculation, because the calculation will take time. I don't want to stop the calculation in the middle. So we have 3 categories, A, B, C. Think about it. What data we have here? We have shape, yes. We have shape. We have three shapes, yes. Triangle, circle, and rectangle or square could be. Make it rectangle, more general than square. Actually, the square, it's a special type of rectangle, so make it rectangle. Okay, so what else we have? What data we have? Color. Color. We have green. We have red. And we have blue. Correct? It's correct. That's correct. I can read it. It's correct. We are not in language class. Okay, what else we have? Size. Okay, size. We have big and small, for example. Okay. Yes. We have other data. Okay, so let's build this tree. What we will take first? It will make big difference what we will take first. Yes. So, for example, you want to take shape? Okay. Take shape. Shape, we have triangle. Yes. We have circle. We have rectangle. Okay. Triangle. What we have triangle. What we have. We will speak about size or we don't have different size. Yes, we have different color. We don't have different color. We have different color, just blue. So we don't have any categories. So if it's shaped triangle, it will be under category B. Yes. If it's a triangle, we have only triangle under category B. We have any other triangle? No. Okay, if it's circle, what we have, we could take color, we could take size, yes? So, let's take which one? For example, size. We have big, we have small for the size, yes? If it's big, it's directly under, because we don't have big circle except in C, or no, maybe this one it's big, yes? So if it's big, maybe we can check what? The color. If it's green, so it's belong to, there's no place here to write. Okay, so I will write it here. So if it's blue, it's belong to category C, and so on. You will continue. Look to this one. We have different decision tree. When we take shape here, we have a decision tree. Here we take color, first one. We have different decision tree. If the color blue, or red or green. If it's red, we have only red in which category? B. So if the shape is, or if the color is red, we are under category B. If it's a blue, okay, we have here different shapes in the blue, but all of them. So here we don't take the size, it's big or small, okay? Size. Because size will not make difference here. Okay, so about shape, we have triangle, square, circle. If it's a blue and a triangle, a blue here color. Let me just blue color and the triangle. We have only blue triangle where here, so it's belong to. If it's a blue and a square, blue square only in category A. So we have category A. If it's a blue and circle only in category C. And so on here. Shape, if it's a green and square, green square only in category B, and the green circle only in category A. Now, if you take shape first, you will have different decision tree. So which one better? The smallest one. Okay, so I mentioned the advantage and disadvantage. So from training set, we have, as I mentioned, possible decision tree. We don't want to learn or use any tree, but means only here, the smallest one. So all our idea here, we need to get the smallest tree because it will be better for generalization and more simple to get classification for the data later. It's common sense, yes? We have a huge tree and we have a small tree for same data. Which one will be easier to understand and faster to classify the data? The smallest one. So to create our model, to create our decision tree, we need to get the simplest or the smallest tree because it's be the shortest one and the best one in terms of processing. We have one approach, which is not possible, creating all the trees and keep only the shortest tree. Yes, we can create all the trees and keep the smallest one. But with the huge data, it's not possible. Yes. Imagine you have many categories, 10, 100. Okay. Each one, you will take it as a root, then imagine under each category of the root, you need another attribute, so you will all the attributes, so you will have too many decision trees. The other way, using some algorithms, one of the most famous algorithm here, it's ID3. It's have another name, C4.5, but we will use this name, ID3. Okay. ID3, we use it to find short decision tree. I did not say here the shortest or the smallest decision tree. I said what? Short. So it will not give you the optimal solution, but it will give you good solution to find a short tree. Of course, to get optimal solution, what you need to do? Find all the trees, then take the smallest one. But it's not good in terms of performance. Yes, you need a lot of processing here. But this algorithm, less processing, yes, but it will not give you the optimal solution. It will give you a short decision tree. Okay. So, or efficient decision tree. So first, the idea, it's about calculating something called information gain. Shortly, the meaning of information gain. When I select any of the attributes means the features, the data of the objects, what its effect on the subcategory and on the tree. So what information I will get if I select this one. This is the idea. Okay. So we have something called attribute selection measure. When you select attribute for a node or for a tree, okay? What criteria you will use to take this decision or in the decision tree to take this attribute? Okay. So the goal of a selection measure is to identify the attributes that will give the maximum information gain. The maximum information for us. Yes, we will get the maximum information about data set. So for each level, each node, we have to calculate the information gain for all the sub data to select which one will be the next, and so on. So it's a repeat of calculation. We use one of the calculation for information gain. It's named entropy. Okay, entropy. I don't need from you to too much focus about the definitions of entropy. In this chapter, we don't focus about definitions, by the way. So what is entropy? Entropy, it's measures the random of the data, okay, or the information. If it's more random, so higher entropy will be harder to draw conclusion, to get conclusion from. So we need less entropy, but Jam, you said we more information gain. Yes, we use entropy to calculate the information gain. You will see that the entropy, it's minus, yes, value. So we use it, it's not totally minus. We take it as minus, but the loop in some cases or in most cases will give minus, so it's become positive at the end. So we use this entropy to calculate the information gain. So entropy, it's measure the randomity inside the data. Okay. Less random means more information gain. So after we calculate the information gain, When we have more information gained, this means we have less randomity in the data. So we select it because it's give us better conclusion for classification. Okay, how to calculate the entropy? So entropy of S. What's the meaning of S? It's the attribute, the category. So S means set of data. So entropy for set of data, it's equal the probability of the subclasses of this data multiplied by log 2 for the probability of this subclasses. Okay, what if we have more than one classes? So it's summation. Okay, for example, we have S, which is the whole data set, for example. We have classes, which is the general class, class 1, class 2, class 3. So what's the probability of class 1 log the probability of class 1 minus, of course. Don't forget the minus. Minus the summation of the probability of class 2 multiply log 2 probability of class 2 and so on. So for example, if we have here 3 items of set S under category C1 and 2 items divided by 9. We have how many one here? It's 7, 9. Yes. Probability of C of the whole data set, what? 3 out of 9. So it's minus 3 out 2, 3 out minus the second one, which is category 2, which is 2 out of 9 log 2, 2 out of 9. And then category 3. And then set of data S, and so on. Of course, later we will have subset for this S, then we will calculate for the subset, then another subset, and so on. When you take any item for the node, then you will calculate the subset for it. So same idea here. So we have minus, don't forget here the minus, minus probability of the third category, which is 4 out of 9 log 2 same, which is 4 out of 9. How to calculate in the calculator log 2? Yes? Not all calculator can calculate log 2 directly. So log 2 of 1, for example. How to calculate it? In the mathematics, log 2 of 1. Okay, I don't ask if it's 0 or not. How to calculate it? It's equal len 1 divided by len 2. So if your calculator do not have advanced calculation for log 2, so you can make it len of the number divided by len of 2. Okay? Any basic calculator will have len, except the one with only numbers. Numbers with the plus and minus. It will not help you. I don't know how to calculate the len. Go and search if it can be calculated with the plus, minus, multiplication. I don't know. Okay. So this is how to calculate the entropy. But how to get information gain from the entropy. This is our idea. Okay, so this is a general term for entropy. So entropy of S is summation from 1 to C. C, what's the meaning of C here? How many categories for this set S? Okay, so entropy of set S have, for example, 3 categories, as we mentioned here. Okay, in our example. So we have 1 from 3, for example, minus, where is it? Okay. So minus probability of I. What's the meaning of I? Category 1, category 2, category 3, or subcategory 1. Okay, so how many different data of this category with this set? Okay, or subset. Later we will see it. So I give this example. It's same example, but with different data. If S, it's have a collection of 14 examples. So I mentioned the examples before. We said when we run out of examples, we don't have more subcategory. The meaning of examples means classes and set. Okay, so if we have set S that have 14 different examples with 9 yes, 5 no. So the total, how much? 14. What's the probability of yes? 9 divided by 14. What's the probability of no? So this yes. What's the probability of no? 5. We have 5 no out of 14. So this is a probability of no. This is a probability of yes. Okay, so entropy of S equal minus, now we will speak about the category yes, then the category no, or the class yes and the class no. So probability of yes, log 2 probability of yes, minus probability of no, log 2 probability of no. Then you can calculate it. Okay, log 2, 9 divided by 14. Let's use any calculator here. We can use, here we have calculator. So, where's the advanced one? Scientific, okay. So we have length here. So 4 divided by 14, or 9 divided by 14, it's equal. Let's put in the memory. So where's the memory here? Memory store. Okay. So it's len. Oh, it's calculated directly. It's good because different calculator. So len of this one, it's not correct. Yes. Oh, divided by, sorry, divided by len of, okay, len. So we have to put the data, then the len, yes? So memory read len divided by 2 len equal. So it's equal minus 0.6374. So equal minus 637. By the way, to make it possible to get the specific data, usually in the exam, we ask you how many fraction point, how many digits after the dot you will have, 2 digits, 4 digits. You know how to round, yes? You know how to round? If it's 5 or more, it will be rounded to extra 1, yes? If it's less, it will be rounded to 0. Yes, if you don't know how to round, just you have to review how to round the data, okay? Because it's depend on the fraction. Little bit different fraction will make different decision tree, okay? So we can calculate this calculation here easily, just this one multiplied by this one, you get some data here, and then summations is the result. Entropy of S for this one. Okay, so how to calculate the information gain from the entropy? Okay, so the gain of get A from set S. So to select attribute A from set S. How to calculate its gain? It's entropy S minus here. What's the meaning of SV? V is subset of S. So this means when I select A attribute from S, okay, we have, for example, the shape, we have the color, okay, and we have the size, for example. So our set, it's all attribute at the beginning. So S will contain all the attribute. If I select A, means, for example, color, what this will give me gain in the data. So if I have two colors, then I will have two different subset, yes? So SV means the subset. So we have, for example, S1 and S2. So SV, first time will be S1, second time will be S2. So if we have two subcategories, this means we will calculate this one plus calculate it again for the next sub. So we have summation actually here, yes? We have what? Summation. Why? Because usually we don't have only one subcategory. We don't have one SV. We could have 2, 3, depend on the subcategory. I know, like speaking Chinese with you now, because we don't have data. When we will have data, we will apply it. But you have to memorize the rules, then we will apply the data. So what's the meaning of SV? The subset. Okay, what's the meaning here? How many elements in this subset? So how many elements in the subset divided by how many elements in the, let's say, in the original set before make it as subset, multiplied by the entropy of the subset. So don't forget. Out, we make the entropy of the general set before divide it. And here we have the entropy of the subset. If we have two subsets, then this one will be repeated 2 times, one for the first subset, another time for the second subset, and so on. Okay, so if we have attributes A, B, C, for example, A, which is the color, B, it's the shape, C, it's the size, then we will calculate the gain of S with A, the gain of S with B, the gain of S with C, the one with the highest gain, we will take it for the node. Okay, this is a general idea. Now, what the algorithm said for you, it's complicated like this without the example. So let's take the example. I don't need from you to memorize the algorithm. I need it from you to know how to calculate it. But shortly, the steps of the algorithm said, okay, we need to select the root node. How to select the root node? We have to score the highest information gain for the whole category. It will be the root node. Then, for each value V means how many subcategory for the general data. Then you have attribute 1, 2 columns, 3 columns. Then if you have 3 columns, then you have 3 different V. You need to draw branch. We can name it at the beginning A. A means general data. We did not yet select one. Then we have to select which subset will be in each branch. Okay? To do it, for each branch, we have to calculate what? We have to calculate the information gain for each branch. So we will calculate it again. When we stop here, let's take it by example. We stop if we don't have any more categories for the subset. So if all the subset under same category, then we reach the categories, the final category. If all the data in the subset give you category, for example, C1, then doesn't matter what under it, it will be C1. So you reach the leaf. You stop this branch and start with another branch. Okay, so this is the meaning when you stop when the you have only same example of category under the subset, or you don't have more subsets, you will stop. Let's take it with data, then you will understand the algorithm, because I need from you to understand the algorithm, not to memorize it. We have this data. Of course, week end here, it's not part from the data. It's just index, okay? Like numbering the data, that first column, second column, and so on. So week 1 until week 10. So this one, it's not part from the data set. It's only index, okay? And this one, it's the classes. Okay, it's the category or the classes, this one. This, the attributes. So we have whether, parents, and money. So first line of data said, if it's sunny and you have parents and you are rich, you will go to cinema. If it's sunny and you don't have parents, but you are rich, you will go to play tennis. For example, it doesn't matter if it's have a meaningful or not. It's a data here. We will work on this data. If it's windy, you will not play tennis if it's windy, yes? If it's windy and you have parents and you are rich, you will go to cinema. Rainy, have parents. Poor, you will go to cinema. Everyone go to cinema. Rainy and no parents, but you are rich, you will stay in house. But I'm rich. Why to stay in house? Alhamdulillah, I never been rich. There is no university doctor will be rich. So don't be university doctor if you would like to be rich. Okay. But alhamdulillah, everything fine, yes. I'm not poor, of course. I'm not rich, but not poor. Okay. So the idea here, the idea here, the root, whether or parents or money. Which one? Why? How you understand that it will lead to smallest decision tree? You have to know its information gain. So it's information gain. First, you need to calculate the entropy, because entropy, we use it for information gain. So first idea, we need to calculate entropy for S. What is? All the data. All the data. Yes? So entropy for all the data, we have to calculate it first. We get entropy of S. Now we need to calculate what the gain for wizard with S. What's the entropy for parents with the gain, sorry, for the parents with S, with all the data, and what's the gain for money with all the data. Then the one that have more gain will be selected as a root. So first we need to calculate the general entropy. We need it. So entropy of S, it's the probability for each of these classes. We said we need to calculate for each classes. How many classes we have? Okay, all the classes is the 3. We have cinema. Okay, we have tennis. We have stay in. We have shopping. So we have 4 classes, and total number of classes will be 10. So as you can see, we calculate the entropy for each. It's probability for each of these 4 classes. Okay, so probability of how many classes we have? Cinema, tennis, stay in, shopping. Yes. So for cinema, what's the probability of cinema? Okay, 1, 2, 3, 4, 5, 6. So for cinema, we have 6 out of 10. For tennis, we have 2 out of 10. Okay, for CN, we have 1 out of 10. For shopping, we have 1 out of 10. So the entropy of S, it's equal minus probability of cinema log 2 probability of cinema minus probability of tennis log 2 probability of tennis minus probability of shopping log 2 probability of shopping, and so on. The probability we mentioned, probability of cinema, it's 6 divided by 10. Probability of tennis, 2 divided by 10. Probability of shopping, 1 divided by 10. Probability of stay in, 1 divided by 10. Is it difficult here? No, but you need to focus in the calculation. What you will calculate for the root, it will be much easier. But for the subsets, you have to understand what data you need here. So here to calculate it, what you need to calculate, in the calculator, you will calculate len of 6 divided by 10 divided by len 2, yes? Or if your calculator can calculate log 2 directly, it will be much easier for you. I'm not here to teach you how to calculate log 2. You have to calculate log 2 yourself. And you have to get accurate result in the exam. Okay? So if the fraction not correct, the result not correct, it's not my business. Of course, I will see the steps. I will give some marks for the steps, but not the full mark. And if you get the final result correctly without steps, of course, I will give 0. Because the final result doesn't matter for me if you don't have the steps. The steps matter for me if you cannot calculate the final. So if the final result not correct, but all the steps correct, you will get usually good mark here. But if the final result correct and you did not put any calculation, you will get 0. I forget the break. You have to remind me. I can give you break before we continue. Just let me open the attendance for you. So let me just stop the recording because I don't want empty time in the middle.